In example 5, we will start looking at the amount of heat required, which is an energy that's required in temperature exchanges. And one of the formulas we have is that the heat energy Q is given by the mass times the specific heat, lowercase c, times delta T. And we're told that we have a 0.5 kilogram aluminum pan and 25% of a liter of water heated from 20 to 80 degrees Celsius. So in part A, let's start by breaking this into pieces. The change in temperature, which is always the final temperature minus initial temperature, is going to equal 80 degrees Celsius minus 20 degrees Celsius, or 60 degrees Celsius. The mass of the water is going to be the density of water times the volume of the water used. And if you recall, the density of water is 1,000 kilograms per meters cubed. And the volume is given to us as 0.25 liters, and then 1 meters cubed is the same as 1,000 liters. So this tells us that we have about 0.25 kilograms. Notice the connection. This is only for water. So now we can say that the heat for the water is 0.25 kilograms, which is the mass of the water, times the specific heat of water, which we can look up in a table or online, which is 4186 joules per kilogram degree Celsius, and then times the change in temperature, which is 60 Celsius. So this gives us 62.8 times 10 to the third joules. A note here is that sometimes you might find the specific heat given in terms of degrees Kelvin. Know that a change in temperature in Kelvin is exactly the change in temperature in Celsius, so you can use the same value. If we look at the aluminum can, it's going to be the mass of the aluminum, specific heat for aluminum times the change in temperature again for the aluminum. We're told that it's a 0.5 kilogram can. The specific heat for aluminum is 900 joules per kilogram times degrees Celsius, and we have 60 degrees Celsius. It's the same as before, and if we do this, we get about 27 times 10 to the third joule. You'll see that a lot of times they use the 10 to the third because we can rewrite this as kilojoules, which is a unit used a lot in heat, and we can rewrite this one up here for the water as 62.8 kilojoules. So the total heat for part A then is going to be 62.8 kilojoules plus 27 kilojoules, or 89.8 kilojoules. So this is the amount of heat that is exchanged from heating the pan and the water. In part B, we're asked what percentage of the heat is used to raise the temperature of the pan and the temperature of the water. So if we look at for water, the percentage is the whatever was the total for water over the total heat observed. that gives us 69.93%. Automatically for the aluminum, then you can do it one of two ways. You can say either 27 kilojoules over 89.8 kilojoules, which is 30.07, or you can say it's 100% minus this 69.93%, which is the water, which will give us exactly the same value again.